So as we continue our study on systems of equations, we're going to start looking at some nonlinear systems. Before we do that, let's take a quick review at some linear ones, and more specifically, how we solve using substitution. So here I have a relatively easy problem if you've been doing these for a little while, and I want to solve this using substitution. I'm going to pick the top equation and solve for y, and I get y is equal to 4 minus x. That's just moving that x over. Now that I know what y is equal to, I'm going to substitute it into the other equation. So this gives me x minus y, which is 4 minus x, equals 2. Distributing the negative, I get negative 4 and a plus x, negative 4 plus x. And don't forget to bring down that x right here. And then x plus x is 2x. Add 4 to both sides, I get 6 equals 2x. And then divide by 2, I get x equals 3. So that's my x value. Putting it back into the top up here, I'm going to say, okay, 3 plus y equals 4. So y is equal to 1. So when x equals 3, y equals 1, and that is true for both of these. If you put 3 and 1 in, you get 4 equals 4. Put 3 and 1 in, you get 2 equals 2. And so that's the solution to this system. If you were to graph it, that's where they cross. Yes, it would have been much easier to use elimination here and just add up to 2. Adding up to 2, you get y and negative y give you 0, 6 for the x value. 6 equals 2x, and then you could solve and get at 3 for the x value. So even though elimination was easier, I chose substitution because it's going to set us up for the next problem, which is going to be this one right here. On this one, notice that we have a parabola up here and then a line down here. That x squared is a quadratic, right? So we're going to have a parabola either being intersected or not being intersected by a line. So we could have 1, 2, or no solutions here, depending on the case. Now to solve this, you could solve it using any of the 3 methods we've learned so far. I just choose to use substitution on this one, and that's what I'm going to do. I'm going to pick this second equation and solve for y. Subtract 2x from both sides. I get negative y equals negative 2x minus 1. Then divide everything by a negative 1, and I get y equals 2x plus 1. I'm going to take and substitute that in to my y value on the top equation. Don't forget you got the negative there that you have to multiply it by. This gives me 3x squared plus 4x minus what I'm substituting in, which is 2x plus 1. Wrap it in parentheses. Everything equals 7 here. And then we're going to work this out. So distribute your negative. And then combine your like terms. So this becomes 2x. And then I notice it's a quadratic. I want to solve it by factoring. So move that 7 over. Remember, that leading coefficient is not 1, so we got to say 3 times a negative 8 gives me negative 24. And I want factors of that add up to the middle term 2. And so that's going to be 6 and 4, with the 4 being negative. And then factor by grouping. Set each factor equal to 0, and we get x equals 4/3 and x is equal to negative 2. Those are your x values. You still have to go back and substitute them in to get your y values. So that's what we're going to do next. X equals negative 2. Then what does y equal? Well, it's going to be 2 times negative 2 minus y equals negative 1. I'm going to write it here because I'm going to run out of room. So I get negative 4 minus y equals negative 1. Add 4 to both sides, and divide by negative 1, you get y equals negative 3. So when x is 2, y equals negative 3. Do the same thing for 4/3. I'm just going to add a piece of paper here because I'm running out of room up top. So to put 4/3 in, I'm going to say 2 times 4/3, that's where I'm substituting the x back in, minus y is equal to a -1. And then solve from there. So 2 times 4/3 is 8/3. And then what do we got here? We got 8/3 minus y equals, and I'm just going to go ahead and convert this to thirds. I'm going to get -3/3. That's the same thing as -1. And then subtract 8/3 from both sides. I get -11/3 is equal to -y. And then divide both sides by -1. I get y equals 11/3. So when x equals 4/3, y equals 11/3. Now I know that seems strange because there's a lot of fractions. Nothing wrong with fractions. If you don't like that, some students feel kind of uncomfortable when they go to answer something and they get fractions. They say, ooh, the teacher never gives fractions like this. Must be something wrong. Go back and double check. Nothing wrong with double checking. Now, if you want to see this graphically, what's going on with this graphically? Let's take a look at the graph on Desmos. There it is graphed out. We have a parabola, and then it's being intersected by that line there. I've graphed both the ones we just did right here on the left. And if we actually click on these, we can see where the intersections are. We got -2, -3, just like what we had. And then we have, what is it? 3/3 and, not 3/3, what did we say it was? 8/3 and 11/3 there up at the top. Okay? And I just noticed, if we go back and look at this, I wrote it down as x equals -2, and then when I wrote this down below, I put +2 there. That should be a -2. I know some y'all like to call me out when I make a mistake, and I appreciate it, but I caught it before you did this time. Or maybe you were sitting at home watching this being like, he screwed up. But, you know, we all make mistakes, right? So that's how we solve a non-linear system. Let's take a look at another problem here. Boom, there you go. You can go ahead and give that one a try. Pause the video. All right, welcome back. Now, the last one we solved by using substitution. Maybe you don't like substitution. Maybe you like doing elimination. So I'm going to show you how we can do elimination here. When I do this elimination, we can't really eliminate the x's because one is x squared and one is x. And so they're not like terms. Can't really add them and have one be eliminated. But I can eliminate the y's. Currently, they both have a coefficient of 1. I want them to be opposite. So when I add them, it gives me 0y, and the y's cancel out. So I'm going to multiply the whole top equation by -1, and that flips all the signs. And then when I add them, I end up with x squared plus x. The y's cancel out, and then -4 plus 3 is -1. Once again, this is a quadratic, so I'm going to move the 1 over. I get x squared plus x plus 1 equals 0. And I'm going to solve this by factoring. So we've got 1, factors of 1 that add up to 1. Let's see here, I've got, there's nothing really, huh? 1 times 1 does not add up to 1. And so I'm going to actually solve this not by factoring, but by the quadratic formula. So we have -b plus or minus the square root of b squared minus 4ac all over 2a. And so this gives me, let's see, we've got, if we put in, let's label our points. It's always helpful. A, B, and C. And so A is equal to 1. So on the bottom we get a 2. And C is equal to 1. So over here on the left side, this just becomes -4. B squared, well, B equals 1. So we're going to get 1 minus 4. We're going to take the square root of that. And then plus or minus -b, which is going to be -1. This simplifies further into -1 plus or minus the square root of -3 all over 2. And here's an issue right there because we cannot take the square root of a negative number, at least not in the reals, right? So since that is imaginary, this is going to be no solution. You could get no solution by getting some things like we did in the last one where you get an untrue statement when the x's and y's cancel out. Here, there's nothing that makes this quadratic work. So this tells me that these things never cross. In fact, if we look at the graph, this is what it looks like. Notice that we were not solving for the x-intercepts on the quadratic. Remember, we combined the two equations. We're looking to see where these two intersect, and they never do. That's why we were getting no solution there. And so here's a case with nonlinear that we have no solution. Let's take a look at another one. This time I want you to solve one of these by graphing. And so just to kind of do that first, we're going to review solving by graphing using linear equations like this one right here. Solve these two by graphing. All right, I take it that you paused the video and you gave that a try. Let me put a graph down. Remember, when we solve by graphing, we're looking for where they intersect. Wherever they intersect is the point that will work on both of them. So I'm going to graph. If it makes you happy, you can put this in y equals mx plus b. I'm going to say, okay, subtract 3x from both sides and then divide by 2. I will get y equals negative 3x over 2 plus 8. And so this tells me my y-intercept is at 8. 1, 2, 3, 4, 5, 6, 7, 8. And then the slope is down 3 over 2. I'm going to graph my line. Now, when you solve by graphing, you want to be very accurate with your graph. This may not work out so well because I'm using a marker here, but make sure you're at least using a ruler, or if you don't have a ruler, fold a piece of paper and use it as a straight edge, because otherwise you could get the wrong answer. This one right here, you can get y by itself if you want to. I'm going to subtract x from both sides and then divide by negative 2. That's going to give me 1/2 x and then plus 0. So the y-intercept is at 0, and then the slope is going to be up 1 over 2. And I can already see where they're going to cross, but let's go ahead and draw the line anyway. And they are crossing right here at 1, 2, 3, 4, comma 2. Now, if you wanted to, you could substitute it back in and verify. So 4 times 3 is 12, 2 times 2 is 4, and 12 plus 4 is 16. Down below, if I do 2 times 2 again, I get minus 4, and 4 goes in for x, and 4 minus 4 does equal 0. So that point works for both of them, so I know that I was accurate with my graphing there. So that's solving by graphing on linear equations. Let's take a look at a nonlinear one. And I want you to try to solve this by graphing. All right, I take it that you gave that a shot. You paused the video. If not, pause the video now and try again. Let's take a look at this graphically. So 4x minus y minus 5, if it makes you happy, let's put it in y equals mx plus b format. So I've got add 5 to both sides, subtract 4x from both sides, and you end up with negative y is equal to negative 4x plus 5. Divide both sides by negative 1, and you get this for your equation. Not a plus, but a minus there. So the slope is 4, the y-intercept is negative 5. 1, 2, 3, 4, 5. And the slope is rise 1, 2, 3, 4, run 1. That's a steep slope. Now, we need to know how to graph our quadratics. So make sure you go back and review graphing quadratics if you don't remember how. If you do remember how, good for you. I'm going to go over it right now. Let's go ahead and get y by itself right here. So I'm going to subtract 5 from both sides, and I'm going to move all this mess over also. So I end up with y is equal to negative 4x squared plus 8x minus 5. And so let's go ahead and use that negative b over 2a. And remember that if I want to know where the vertex is, it's going to be at negative b over 2a, comma, the f of negative b over 2a. So all takes you back and forces you to review this stuff that we learned back in a previous chapter. Here's my b value. So it's going to be negative 8 over 2 times a. My a is negative 4. And this gives me negative 8 over negative 8, which is positive 1. And so that is the x location of my vertex. To find my y location, I'm just going to substitute 1 back into this. So negative 4 times 1 plus 8 times 1 minus 5 is what I get, which is negative 4 plus 8 minus 5, which is negative 1. And that's where my vertex is when I go to graph this. It's at 1, negative 1, which is right, boom, right there on the line. So that is one point of the intersection. But remember, this could intersect it in 2 spots. This thing is pointed downward, so I know it's pointed downward because of that negative a there. there's probably another spot where it intersects. So I'm going to put in 0 into this function and just kind of test out where it is. I know it's going to be going downwards. So if I put 0 in, I get 0 plus 0 minus 5, which is minus 5. So when x equals 0, y equals negative 5. 1, 2, 3, 4, 5. And right there it is crossing again. I know this is my axis of symmetry, so if I go to 2, it's going to be right there. And here it is graphed. So we can see our solution is going to be at 1, negative 1 and 0, negative 5. Those are our 2 points of intersection. So that takes us through just kind of an introduction to nonlinear systems of equations. Now, we're going to do a ton of practice problems with these, so be sure to ask me questions as you go through them. We might even see some circle equations pop up if we've covered circles in the class already. I'll definitely throw those in there. If we haven't covered them, I won't put them in there. So do your practice problems. Let me know if you have any questions, and thank you for working hard.